So, hello, I'm Michael Tinieri. I'm here from the Generating Power from the Sea exhibition. We're all from Swansea University there. What we're talking about is tidal turbines. And a tidal turbine is essentially, works on very similar principle to a wind turbine. You have a rotor that is driven around by the movement of a fluid, except you're looking at water rather than air. And this works because when you have the tide, you've got a big lateral movement along the coastline of a large body of water. This will hit an obstacle like an island or a headland, accelerate to get around it, and you get very strong currents there. I don't think surfers are going to be that worried about tidal turbines. They're 5 metres or so below the surface, up to 15 metres below the surface, so unless you've got a very big surfboard, you're probably alright. Tidal turbines are an important, or potentially an important contributor to the future of energy production in Britain and indeed around the world, although Britain has a unique position in terms of it's got a much stronger tidal resource than many other countries. So essentially it's important to have diversity in your sources of power because then, for instance, if you have a shortfall in one source of fuel, you can make up for it with another technology. Or if there's a problem discovered with technology, you can move your reliance to another sort of generation. And so we think that tidal power can be another way of another contributor to this solution for the future of Britain's energy production. Grand plan eventually is to be supplying power to the national grid. It's actually one of our industrial partners has done all the hard work of building it. They've built a device that's supplying power to the grid up in Northern Ireland. They're hoping to build a farm of devices that will be going in off the coast of Wales, probably around 2016, 2017. That's going to be the first farm that's going to be actually supplying power on a commercial scale. Eventually, we're hoping over the next 15 to 20 years, you'll be looking at a full or reasonably full exploitation of the tidal resource around the UK, and that could be looking at maybe 5% of all the UK's current energy needs. So it's not going to be the only thing, but it could be an important contributor. In terms of expense, tidal turbines are a relatively young technology, so we're still making the first steps towards commercialisation. So at the minute, they're probably slightly more expensive than onshore wind, maybe roughly in parity with offshore wind. But as we move towards greater commercialisation, people are starting to learn from their mistakes, and it's becoming cheaper as people essentially get more expertise in the construction and maintenance of these devices. One of the most important things about science is it's a learning process. You've got to make mistakes before you can figure out how to avoid them again. There are lots of ways, lots of different paths to science that could help develop this technology. We need people who are not only engineers in terms of designing the turbines, but also in terms of trying to design the operations, figuring out the best way of building them and putting them in place and maintaining them afterwards. We need lots of biologists who are going to be looking at the behaviour of the fish and the marine mammals around these things, people who are dealing with the shape of the seabed, transport of sediment and so forth. All these people are feeding into the future development and the future of the science in this technology. So it's a call to all the young scientists out there, we need you in this field as well.